Good. Teaching area of a sector and area of a segment. If you check this, let's look at this activity 3. If you look at this diagram, that is a sector. Now, if you open your eyes well, you can see that this sector has been separated into 2. That is the upper part being a triangle and the lower part being a segment. I hope you can see that. Good. So, if that is what you can see, then bravo. From the activity above, a sector can be divided into a triangle and a segment. If you can see that, good. Activity 4. We want to establish the formula of area of a sector and segment. Area of a sector is theta over 360 multiplied by the area of a circle, that is pi r squared. Yes. The area of a sector is part of an area of a circle. That is what I want you to understand. Now, area of a segment, that is this part, is area of a sector minus area of the triangle. Let's go back a bit to see. So if I want to find the area of this segment, then this area of a area of a triangle will be subtracted from the total area of the sector so that you get the area of the segment. I hope you can see that. If this one goes here, like normally we say it crosses, it doesn't cross. But I hope you can see what I'm trying to say. Thank you. So that's it. Now, area of a triangle AOB equal to half of AB, that is base length, multiplied by OP, the height of the triangle. Good. AB and OP. So when you multiply the length of that is the base of the triangle by the height of the triangle, then you multiply by half to get the area of this triangle. I hope you can see that. Good. Now, what about if you want to find the length of AP and OP? By using trigonometry, AP will be r sine half of a theta and OP will be r cos half of a theta. I hope you can do that. You can do that by, normally when do we say, what's the sign? We will say opposite over hypotenuse. What about cos? Adjacent over what? Good. So that's the strategy we are using. Hence, area of triangle AOB will be half of this multiplied by that. Good. So technically, this half, that is this 2, will cancel this 2. That is the coefficient of the R. Can you see that? Hence, in that case, you find out that you have this R and another R here. Good. Because the 2, that is the equation of the R, will be taken care by the half there. So basically, you have the 2 R's multiplying to get R squared. I hope you can see that. So sine half of a theta multiplied by cos half of a theta. Then you are multiplying by the 2, that is R squared. I hope you can see that. One R is here, and another R is here. Good. Then we are subtracting that from the area of the segment. sorry, yeah, the area of the segment, sector rather, the area of the sector rather. Thank you. Let's check this, our first example. Find the length of the chord AB. Then we are also to find the area of the shaded region. What is the name of the shaded region? Segment. Thank you. Good. Now we are to find the base of the triangle, that is AB. So we use this to find. Good. Then this is the area of the sector. We subtract the area of the triangle. The area of the triangle. So what do we get? 3.252 centimeters. If you take your time and you work it out on a separate sheet of paper, you will get that. But for whatever happens, you can draw my attention and ask further questions. Thank you. Example 2. A chord PQ. Chord PQ. Good. Of a circle of radius 5 centimeters. Subtends an angle of 70 at the center O. We are to find, correct to trace significant figure PQ, that is length of PQ. Length of PQ. That is the chord. Good. Then we are to find the area of the sector. That is the triangle plus the segment. That is the sector. Then we have to find the area of the minor segment. That is this, the smaller one. So, PT to find PT, that's it. 5 sine 35. Where from the angle 35? Do you see that we have divided the angle 70 into 2? So that is what we are using. The other one, if you could remember, it was angle 40, but we divided it into 2020. Do you remember? It's the same thing we are doing here. So now we want PQ. So we multiply 2 by 2.869, and we are getting 5.7357. So approximate this correct to trace significant figures, then we are getting this. Thank you. We are continuing now. The question number 2, that is the arc length. The arc length. Like I said, an arc is part of the circumference. So it's a fractional part of the circumference. So theta over 360 multiplied by 2 pi r. Then we get here. Then this is going to be our answer. This is going to be our answer. Good. Now somebody may ask, why are we using angle 70? Now we are not talking about the triangle again. We are talking about finding the arc length of the sector. So we are using all the angle that sustains there, and the angle that sustains there is what? 70. Don't confuse with finding the part of the triangle. Thank you. Answer for question number 3. The area of the sector. Good. So area of a sector 2, we are maintaining the 60 degrees because is a part of the 360. Good. Then you're going to get this 15.278 centimeters square. This is also another one. That is question number 4. For the area of the minor segment, you need to calculate the area of the triangle so that you subtract the area of the triangle from the area of the sector to get the area of the segment. Like I told you, the area of a sector is divided into 2. The upper part is a triangle and the lower part is the segment. So if you want to find the lower part, which is the segment, then you have to subtract the area of a triangle from the area of the sector to get the area of the segment. Good, if you could remember that. But anyway, so first of all, let's look at the area of the triangle. Half base times height. If you check the diagram, the base is PQ and the height is OT, if you could remember. Thank you. Now, we know the PQ, that is the base. So, from the trip ratios, now we are dividing the angle 70 into 2 because we are talking about the. You know that this height will divide the angle 70 into 2 because the height is perpendicular to the base of the triangle, if you can check that. Thank you. So cos 35 is helping us to find the height of the triangle. So the height of the triangle will be 4.096 centimeters. Hence, for area of the triangle, half base times height. When you substitute the PQ, that is the PQ, and the OT into the formula, you get 11.7474 centimeters squared. So now for the area of the segment, we are now subtracting the area of the triangle from the area of the sector to get 3.531 centimeter squared. So basically, we were looking for the area of the triangle and the area of the sector. And the area of the sector, let's go back. Okay, it's okay. The area of the sector, I think we already know that. Then this one helps us to find the area of the triangle, POQ. And we put it inside this to get the area of the segment. Thank you.